domain and range. Your domain are all your inputs. Generally speaking, they are all the x values. All you're required to do is to give the set from the domain, and that would be 5, 3, 4, -1. You do not need to repeat something that's there more than once. Your range are all the corresponding y values, 2, 2, -3, 5, -1. Okay, so you list all your x's, list all your y's. That's all you have to do on that. The relation is not a function. Please explain why. 13.8, 13.2. Those are the two that violate my rule. I have 2 y's for 1 x. Each x has to have its own y. Or only 1 y for only 1 y for each x. They may have, all the x's may have the same y, but you cannot have more than 1 y for 1 x. For the next one, this is really kind of easy. Find f of -3. So f of -3 is 2 times -3 squared minus 3 times -3 plus 2. Take x, replace it with -3. Take x, replace it with -3. Now, -3 squared, that's 9. 9 times 2, there's 18. -3 times essentially -3, that's plus 9. Plus 2. Let's see, 10 plus 18, I get 28. Or sorry, 20 plus 9, my bad, 29. 29, yeah, 29. 10 plus 2 is 20, plus 9 is 29. My bad. Questions? Okay. If y varies directly as x squared and y equals 4 when x equals 7, what is y when x equals 3? Do not round off. See this right here? See this? Do not round off your answer, which indicates you probably don't want to do decimals. So y varies directly as x squared. It's the first thing you do. Write down the relationship and then plug in the numbers. I have a y and equals 4 when x is 7. So that means I have 4 over 7 squared equals, I don't know, over 3 squared. Just plug them in. Notice I didn't square anything yet. All I did was plug the values into the relationship. So 4 over 49 is equal to y over 9. Multiply both sides by 9. 36 over 49 is equal to y. 36 over 49. See, look, I didn't round off my answer. That is exact. Anything else will be an approximation because it's a repeated decimal. Anything over a power of 7 is a repeated decimal. Is the equation y equals 3x plus 1 a direct variation equation with the constant of variation is 3? Is that yes or no? This is a simple question. Yes or no. Either it is or it is not. Can I write this as y equals kx or y over x equals k, where k is equal to 3? Can I do that? Can I take y equals 3x plus 1 and make it look like one of those? No, because of the plus 1. So this is a no. It's a simple question. It's a simple answer. Yes or no. Not, I don't know. Okay. Determine whether y varies directly with x. If so, find the constant variation. So what you have to do is you have to take y and divide it by x. And see if you get the same number each time. Is y divided by x the same each time? This is 6. This is 6. This is 6. And yeah, this is 6 as well. So, is it direct variation? Yes. What is my constant of variation? It's 6. Notice how I have my answers. I did not put in the direct variation what K was. I answered that question. I answered the first question. It's a yes or no. Is it or is it not direct variation? It is a yes or no question. There should only be, there's 2 possible correct answers. 2 possible correct answers for this first box. Yes and no. I know, you're looking, you're like, yeah, that makes sense. Yeah, no, you don't grade the tests, I do. There are 2 possible correct answers there. Okay. And then this one, there is 1 possible answer. If this is yes, you answer this. If this is no, there's no need to answer that one because it's not direct variation. There is no constant of variation if it's not direct variation. Okay. This should only be filled in if that one is a yes. I say these things, yet there are people who do not listen to me. For example, on the last test, you had to give the identity and listed the 4 possible answers. And everybody on the test actually used only those 4 things, but somebody on the makeup test on the retake gave me an answer that wasn't one of those 4 choices. Okay. State the x and y intercepts. Remember, to find the x-intercept, you let y equal 0. So you get 5x is equal to 30. So x is equal to 6. To find the y-intercept, you let x equal 0. Negative 2y equals 30. So y equals negative 15. Watch your negatives and positives on these. Write the equation of the line in slope-intercept form, giving the slope m equals negative 2 and the y-intercept is negative 4. So this is my m. This is my b. Slope-intercept form, remember, is y equals mx plus b. I'm given the m and the b is just a plug and play. Y equals negative 2x. Sorry, minus 4. That is probably the easiest equation to write, as you're just plugging in the 2 values. Okay, find the slope of the line passing through the point. You need to find the slope. You use the slope formula. Change in y over change in x. Y is on top, x is on the bottom. It does not matter which point comes first. If you do it correct, you'll get the same answer. Negative 3 minus 6 over negative 1 minus negative 4. Once again, notice I just plug everything in the first time. I don't simplify until it's written down, and then I simplify. Make that a double positive. 2 negatives make a positive. Negative 3 minus 6, I get negative 9. Negative 1 plus 4 is 3. That's negative 3, so my slope is negative 3. Okay. Right, the equation of the line in slope-intercept form, perpendicular to that, and passing through the point 3, 2. So, to write the equation of the line, point-slope form, I need the point, which I have. I need the slope, which I can get. It is perpendicular to this one. The slope of this line is 4/3. So the slope of my new line is negative 3/4. Okay, negative 3/4. That's the slope of my new line. Opposite, inverse. Point slope, fill in the blanks. My y-coordinate is 2, my x-coordinate is 3, my slope is negative 3/4. I need to rearrange it to get a y equals. First step, distribute the fraction. y minus 2 is equal to negative 3/4 x plus 9/4. I can't reduce that. So leave it that way. And then I need to add 2 to both sides. Y equals negative 3/4 x. And then 9/4 plus 2 is 9/4 plus 8/4. Right? Have to have a common denominator to add fractions. 9 plus 8 is 17/4. I make no promises. I try not to have fractions, nasty fractions on the test, but I make no promises. But you have a calculator, and your calculators do fractions. At least mine does. Okay. Write the equation of the line. Y equals negative 1/7 x minus 3 in standard form. X's, Y's equals numbers, no fractions, no decimals. First step, get rid of the fraction. Multiply everything times 7. Common denominator. So I get 7y equals negative x minus 21. Add x to both sides. I get x plus 7y equals negative 21. As some of you found out the hard way on the lesson quiz, order matters. X, y equals number. If you don't have x, y equals number, you're going to get it wrong. It's one of the few times, one of the very few times, I am a stickler about how the equation looks. It's supposed to be in a particular form. This is a particular form. Standard form, x, y equals number. No fractions, no decimals. Okay, as a new car gets older, time increases. The value of the car typically decreases. Which type of correlation does this represent? So what they're saying is, I have time and value. As time goes this way, value goes this way, so it's going down. That would be a negative correlation. And that is extremely typical. Okay. Consider the data set below. True or false, the trend line shown below is a reasonable approximation of this data. Does that line reasonably pass through the data points? Yes. And those are the correct data points, right? 0, 5, yeah. True. Because my answers, my possible answers are true or false. Not, I don't know. IDK is not a correct answer. Not even one of the choices. Okay, true or false? The equation y equals negative 5 halves x minus 2 is a reasonable approximation. Well, minus 2 goes through here. And let's see, over 2, 1, 2, up 5, 1, 2, 3, 4, 5. Is that a reasonable approximation of the data? Does that fit the data points? No, it does not. So this would be a false. Slope is good. The slope is good because that's the slope of this line. But my y-intercept is negative. Is not negative 2. My y-intercept would be 5. Okay, given from the point 0, 5. But negative 2 is where the x-coordinate is, and that's probably where that mistake is going to lie. But you got to know and do what I did. Graph the line. Take the equation that's here, graph it, Does that line fit the data? True or false? Okay, when compared to the parent graph, y equals x squared, what is an equation that is narrower with a vertex of -2, 3? So here's what you're trying to do. You're trying to fill in the H, the K, and the VA appropriately. That's my H, that's my K. So I get y equals x minus -2 squared plus 3. Two negatives make a positive, although if you left negative minus -2, I'd be okay with that. And then the other part of it that I need to know is it's narrower, which tells me what about the A? It's a number larger than 1. If it's narrower, it's a number larger than 1. If it's wider, it's a number smaller than 1. So any number larger than 1 would work. Because the larger the A, the skinnier the graph. The smaller, the wider it is. Okay, what are my possible answers to each one of these four? True or false? It's either true or it's false. So consider the transformation of y equals x squared to y equals 2 times x plus 2 squared plus 3 and answer true or false to each of the four statements below. The graph is flipped upside down. True or false? False, because this is positive. To have it be flipped over, the A would be negative, so it's false. The graph is narrower. True or false? True, because this number in front, the A in front, is larger than 1. This is true. The graph is shifted to the right 2 units. The plus 2 means that I go to the left 2, inside opposites. This would be false. And then the graph is shifted down 3 units. The plus 3 outside means that I go up 3. Outside's the same, inside's the opposite. So it's not shifted down, it's actually shifted up. This is false. So you have to understand what those transformations are. What does being inside the parentheses do? What does being outside the parentheses do? What does being something slapped up in front do? And remember, absolute value does the same thing, only instead of being squared, it's absolute value bars, but the transformations do the same. Okay, graph both y equals x squared and y equals x plus 2 plus 3, excuse me. X squared y equals x plus 2 squared plus 3. The plus 2 inside means that I move my vertex to the left 2. The plus 3 means that I go up 3. Over 2, up 3. There's my new vertex. There's my second graph. The vertex is the first thing I look for. Is the vertex in the right place? After the vertex, I look at wide and narrow. I look at pointing down if it needs to point down. Same thing on this one. Do the absolute value of x. Parent function. Graph. Absolute value of x minus 1 minus 3. The minus 1 inside means that I go to the right 1. The minus 3 means I go down 3. Over 1. Down 3. And there's my new graph. That's what I'm looking for. It's exactly what I'm looking for. Where's the vertex first and foremost? Did you get the vertex transformation correct? The shifts horizontal and vertical. Did you get that correct first? And then anything wide or narrow, I go after that. Graph and shade the inequalities. So first one, I'm going to do this. It's y-intercept slope intercept. So there's 1 for the slope for the y-intercept. My slope is 2 over 1. So go over 1 up 2, and it's a dashed line. And then I test, and I can test the origin because it does not pass through the origin. Is 0 greater than 0 plus 1? Nope. So this is the origin, doesn't work. So it shades the other side. This one, there are 2 graphs on the same one. I'm not looking for a melding of both of them. I just want to know both of them. Graph and shade those 2. First one, y is greater than -2. And it's a dashed line through -2. And I want everything above. And then I graph the other one. 4x minus 3y is greater than or equal to -12. This one I use x and y intercepts. Let x equal 0. Minus 3y equals -12. Y equals 4. Dot on 4. Let y equal 0. We get 4x equals -12. So x equals -3. Get -3. This one's or equal, so it's a solid line. Okay. Pick a point. The origin is the easy one to test. 0 minus 0 greater than or equal to -12. Is 0 minus 0 greater than or equal to -12? Yep. 0 is bigger than -12. There you go. This might give you an idea that bringing colored pencils, at least 2 or 3 of them, to the test would probably be a good idea to have a couple available for you. The idea of maybe having a highlighter to shade one side or the other. And if you do bring a highlighter, bring more than one color, because if you have to share a graph with 2 of them, you want to keep them separate. Makes my life easy. And you want my life as easy as possible when I grade your tests, right? Okay, performance task, A, B, C, D, E. Okay, a lot of steps to this performance task. Take them one at a time. First one, part A, draw a line through those 2 points. Plot the points, draw your line through those 2 points. 3, -5, 1, 2, 3, 1, 2, 3, 4, 5, and -3, -2, 1, 2, 3, 1, 2. There's part A. Hopefully you'll get A. I have kids that leave that blank all the time. Find the slope of the line. Slope equals, plug in the values. -5 minus -2 over 3 minus -3. So that's plus, so I get -3 over 6, -1/3. Here's my slope. No, 1/2. You're right. You're 1/2. My bad. Thank you for pointing that out. -1/2. Thank you for catching my error while it's on tape. Okay. Next one. Write the equation line in mx plus b form. Now, a lot of students are tempted to go, oh, I know my y-intercept. My y-intercept is, oh, crap. I don't know if my y-intercept is -4. I don't think so, but it could be. depends upon how good you are and how much you trust your line when you graph it. I wouldn't if I were you. I would never trust my line to do my mx plus b from to find my y-intercept. I would never trust it. You must be really super awesome at graphing in order to trust that you're going through exactly that point. I would never do that. What I would do is set up this and rearrange it. Minus 1/2, that's my slope, and pick one of the 2 points. I'm going to go with -5 and 3. Doesn't really matter which one. Make that a plus. Y plus 5 equals, distribute my -1/2. 1/2 x plus 3/2. Add 5 to both sides. Or sorry, I should say subtract 5 from both sides. -1/2, -3. What's a negative and a negative do? Yes. Oh, sorry, that one. Yes, you're right. -1/2. Sorry. So I'm going to have y equals -1/2 x plus or minus something. So I have 3/2 minus 5, which is 3/2 minus 10/2, which is -7/2. Gee, it's not 4. It doesn't look, it looks like it goes through -4, kind of, sort of, maybe, but it's not close enough. It isn't. Do not trust your graph for finding your y-intercept. You never know for sure. You might get lucky. You might not. And I have a lot of students that think they're going to get lucky, and they're not. Okay? It's better to be smart than lucky sometimes. Sometimes it's better to be lucky. I'll always admit that. Okay. Rewrite this equation in standard form. Y equals -1/2 x minus 7/2. My first step, multiply everything times 2. 2y equals -x minus 7. Add x to both sides. X plus 2y equals -7. Get rid of the fraction, move the x's over. You got to do. Part E. 2 parts to E. Okay. Go back to the coordinate grid. Draw another line perpendicular to this one through the point -1, 2. So -1, 2, that's this point here, perpendicular to that. I would not trust being able to draw a line at a right angle with 1 point. What I would do is, if the slope of this line is -1/2, the slope of this one is 2. Perpendicular lines, opposite inverses. Over 1, up 2. Found my slope. There's my line. That's one part of that. Second part, give me the equation of this line in mx plus b form. Plug and play. Put in my slope, put in my new point, rearrange, distribute the 2, like that, so I have y minus 2 equals 2x plus 2. Add 2 to both sides, y equals 2x plus 4. Questions? I do believe that's it.